Something extraordinary has appeared in the cosmos, a ghostly radio ring nearly a million light-years wide. Invisible to human eyes, yet blazing in radio waves, it stretches across space on scales bigger than galaxies. Astronomers call them odd radio circles, ORCs, and their sheer size and mystery have left scientists baffled. Using artificial intelligence, cutting-edge telescopes, and painstaking verification, researchers have uncovered brand new ORCs, alongside strange companions that don't fit existing categories. What are they? Where do they come from? And why are they only now being revealed? 1. Ghost rings in the sky, a million light-year mystery. Imagine mapping the radio sky and stumbling upon a circular ghost, so faint you'd miss it if you blinked. That's exactly what astronomers encountered while combing through enormous data sets, colossal odd radio circles. Unlike galaxies, which shine across optical and infrared light, ORCs are silent in nearly every wavelength. They exist only in radio frequencies, forming gigantic rings that seem almost sculpted across intergalactic space. The scale is mind-bending. The largest span close to a million light-years, dwarfing the Milky Way several times over. The breakthrough came through the EMU, Evolutionary Map of the Universe, survey using ASKAP, the Australian Square Kilometre Array Pathfinder. Covering over 4,500 square degrees of sky, EMU is designed to catalog millions of radio sources. Hidden among the countless signals were patterns so faint and diffuse they would have been dismissed as noise in earlier surveys. Instead, through the clever pairing of machine learning algorithms and sharp human eyes, researchers spotted the first hints of ORCs, faint, perfect circles glowing only in radio. One ORC stood out. Its host galaxy revealed an enormous spread of ionized gas, extending roughly 40 kiloparsecs. For comparison, our galaxy's gas halo reaches only a fraction of that. The radio ring stretched even farther, orders of magnitude beyond the galaxy's visible boundary, hinting at forces powerful enough to hurl matter across intergalactic space. It was not a feature that could be explained away as a quirk of imaging. It was real, structured, and enormous. The shock doesn't come only from their size. It's also their invisibility. In optical images, there's nothing unusual. Infrared scans reveal no clear counterpart. Even X-rays, which usually trace energetic outflows or hot gas, come up mostly empty. These are cosmic phantoms, detectable only when you tune into radio waves. That raises immediate questions. What mechanism could inflate such a vast bubble and leave no multi-wavelength trace? Why do they form circles so geometrically perfect? And why are they so rare? Only a handful identified despite scanning millions of galaxies. The very existence of ORCs challenges the boundaries of current astrophysics. Galaxies are familiar, supernovae are common, and even black holes leave signatures we can track across light spectra. But these rings resist easy classification. They aren't supernova remnants. They're far too large. They aren't the typical lobes from black hole jets, which are elongated and directional. ORCs are spherical, symmetrical, and out of proportion with known processes. In essence, this discovery tells us we've been missing an entire class of cosmic structures simply because we didn't have the right instruments. Now that they've been spotted, the race is on to explain them. The more we find, the stranger the picture becomes. And the real intrigue lies in how astronomers actually manage to detect such fragile, hidden giants in the first place. 2. The monster discovery that shouldn't exist. The discovery of ORCs wasn't a stroke of luck. It was the product of a systematic hunt, a marriage between artificial intelligence, high-resolution radio mapping, and old-fashioned human scrutiny. The challenge was simple but overwhelming. ASKAP's EMU survey produced millions of radio detections. Buried inside that avalanche could be objects unlike anything ever seen. But how do you find rare patterns among millions? Enter machine learning. Astronomers developed an algorithm called GALDINO, part of the MeerKAT system, trained to identify unusual morphologies. Conventional radio galaxies appear in predictable shapes, cores with jets, lobes, or compact sources. But ORCs are different, large, faint, circular. The AI sifted through 3 million postage stamp cutouts of radio sources, each 8 arc minutes across, and flagged anything with a high probability of being ring-shaped. that narrowed the overwhelming flood of data down to 1,794 promising candidates. But computers aren't perfect. Algorithms sometimes mistake noise, image artifacts, or overlapping sources for real structures. That's where humans came in. Astronomers manually inspected every flagged candidate, rejecting false positives and confirming the real oddities. Through this process, they isolated 5 genuine ORCs and 2 additional possible cases. For objects this rare, every confirmation mattered. Cross-checking was vital. To confirm the cosmic nature of ORCs, researchers compared their radio maps with optical surveys like DES and infrared scans from WISE. The goal was to identify host galaxies or clusters at the centers of the rings. In one especially compelling case, spectroscopic follow-up revealed O2 emission lines from ionized gas, confirming that the central galaxy was not only active but driving winds, or shocks on a colossal scale. What makes this approach groundbreaking is the balance of automation and intuition. Without AI, the ORCs would have drowned in noise, dismissed as too faint to notice. Without human judgment, AI would have delivered dozens of false detections. Together, they became a filter fine enough to catch some of the faintest, strangest structures in the universe. The process didn't just turn up ORCs. Along the way, researchers found 55 other unusual objects, labeled glares, galaxies with large-scale ambient radio emission. These aren't neat circles, but diffuse clouds or rectangular halos of radio glow around galaxies. They may represent earlier or transitional stages in the same energetic cycle that produces ORCs, giving astronomers a timeline to work with. Are glares the before picture and ORCs the after? That remains to be proven. This new frontier is about more than clever tools. It shows how astronomy itself is changing. We're moving from cataloging what we expect to see to letting algorithms uncover the unexpected. Each ORC discovered through EMU doesn't just add to a list. It forces new theories, demands deeper observations, and pushes technology forward. And that leads directly into the real puzzle. What cosmic process could possibly carve these ghostly rings? 3. AI hunts down the universe's hidden giants. Theories abound, but none fully explain ORCs. The most obvious candidate is the activity of supermassive black holes. When black holes at galactic centers accrete matter, they can unleash titanic outbursts, driving jets and winds that reshape galaxies. Perhaps an especially violent burst inflated a spherical shock wave, leaving behind the radio-bright halo we now see. Yet the symmetry of ORCs is suspiciously neat. Black hole outflows are directional, producing lobes, not circles. Could these be rare cases where energy was released isotropically? If so, what triggered it? Another leading hypothesis involves galaxy mergers. When galaxies collide, gas is shocked, stirred, and thrown outward. X-ray studies of the so-called cloverleaf ORC suggest exactly that: intragroup gas disturbed by multiple interacting galaxies. The cloverleaf's unusual four-lobe shape aligns with the idea of collisions sending shock waves through the surrounding medium. If true, ORCs may be signposts of galactic violence on intergroup scales, their rings echoing across millions of years. But the story doesn't end there. Observations show that in at least one ORC host, ionized gas extends over 40 kiloparsecs, far beyond ordinary galactic halos. This suggests winds or outflows that are extraordinarily powerful, capable of reshaping not just a galaxy, but its environment. Such processes may represent a missing piece in galaxy evolution models. Explosive phases where matter is expelled so violently it creates structures visible long after the central event has faded. The rarity of ORCs deepens the mystery. If they come from black hole outbursts or mergers, why don't we see thousands? Is it because they are short-lived, lasting only a brief cosmic moment? Or are they so faint that even with our best instruments, most remain invisible? Their scarcity could mean they mark only the most extreme episodes in galactic life, reserved for conditions we barely understand. And then there's the speculative side. Some have wondered whether ORCs could represent signals from advanced intelligence or unknown cosmic engineering. While mainstream scientists treat such ideas cautiously, the fact remains: ORCs defy easy categorization. They don't look like natural leftovers of ordinary events. Their perfection and invisibility outside radio make them hard to dismiss as just one more galaxy quirk. What's certain is that ORCs point to gaps in our knowledge. They remind us that galactic evolution is not a smooth process of star formation and slow growth. It's punctuated by outbursts, collisions, and shocks so vast they leave million light-year scars across the cosmos. Each ORC may be a fossil record of one such cataclysm, a whisper from a time when galaxies reshaped themselves in ways we've only begun to imagine. If black holes and mergers don't fully explain them, what else is out there? That's the question driving astronomers deeper into this mystery, with every new survey holding the promise of more discoveries that could upend what we think we know about the universe. Odd radio circles are not just curiosities. They're cosmic landmarks pointing to events on scales we've barely begun to comprehend. Through AI-powered detection and meticulous follow-up, astronomers have uncovered structures that challenge every model of galaxy evolution and cosmic energy release. Whether they're the echoes of black hole outbursts, the scars of galactic collisions, or something entirely unexpected, ORCs are rewriting astronomy's rulebook. What they ultimately reveal could transform our understanding of the universe's most extreme forces. Stay curious, because these ghostly rings may be just the beginning of a much bigger cosmic story. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.